We are talking now on ingestion data from web pages. So the technique is that of web scraping. So the possibilities of creating a process that goes on some web page to take a piece from the web page. The mechanism is reported in these slides, so it's possible to use the web scraper, in this case Portia web scraper. Is possible to define a process for web scraping, so to identify and select visually which are the data to be grabbed from a specific web page. This information is going to be enforced in a process that is Dockerized, so is transformed in a background process that can be activated when needed. So the activation can be performed by an IoT app. So is the process is transformed in a microservice that can be activated when according to the flow, and the data grabbed from the web page arrive directly inside the IoT app, on which it can be transformed and maybe processes to be ingested definitely into the brokers or into the MyKPIs, or to be sent directly on the dashboard. The mechanism is depicted in this test case, so you can access from the portal to the user manual in which is explained how to do it. You can visually open the web page of your interest and select visually which are the elements that you would like to grab, to scrape. Once you have done, you can call this process in a manner, and so your portal crawling, it can be activated with some timestamp or with some message in the input, and the process is going to grab that page and produce the results in some manner that can be converted in JSON, for instance, or whatever. So this is the example of grabbing, for instance, the web page of Digipolis, in which we extracted the sum of the events, and the events regarding the events managed by Polis in Antwerp are addressed and extracted by the process, by the Portia process. Another interesting aspect is the data stream from Smart City API, participatory aspect. So it's possible to make ingestion of information coming from Smart City APIs. The Smart City APIs are typically used by the mobile app and so on. So the users can click on perform click on app, or post an image, or post a comment on a point of interest, or post a ranking, filling a questionnaires, or moving around, and so generating trajectories, or also sending data OBD2. So all these data are contribution that came from the mobile phone, on the mobile app, to the Smart City infrastructure, passing through the Smart City APIs. So this is a very important source of data, because you can extract origin destination matrix, you can extract trajectories, you can understand how the people move, and so on. From the mobile device, the data ingestion is performed directly from the front end. So you have the mobile device interact with the Smart City APIs, and this information is directly ingested into the Elasticsearch or into the MyKPI database. That could be a MySQL, or could be and an Elasticsearch as well. So as already mentioned in other case, and is going to be described better in the in the final section, the mobile app are typically bidirectional device. They are used to receive information, to pass information to the user, but also to produce a lot of information for the platform. So to know where the people are moving, or which kind of menu have they selected, what the point of interest they preferred, which dashboard they accessed, which search they performed, which kind of routing, which voting, which comment, which image, etc. What they subscribed, for instance, to have a notification on which kind of pollutant and which they are afraid, and so on. So the app really produce a lot of information. The app produces a lot of information and is going to receive from the platform suggestions and engagement and notification. This arrow should be on the other side. So from this data is also possible to compute some derived information like trajectory, hot places, origin, destination, matrix, and so on. So with some data analytics, is possible to understand and to perform, to extract a lot of more information. So this is a word divided by two. So the one thing is what the user does in the app. The app is a means to understand the needs and the preference of the user, and the system can react, sending information and so on. So in this sense, the platform can be used for user engagement, so to send the stimulus to the users according to their context. And the context is the available data that we are going to ingest automatically. So the user engagement can inform, engage, stimulate, and provide the bonus and reward when needed. And this is the tracking. Also the trajectories of devices that can be produced by the GPS position of the app, or can be produced by the ODB2 data, and with augmented GPS position can reach the system. For onboard unit can reach the SIM as well with GPS information. Again, that are onboard unit are typically boxes or vehicular kit that are installed by the insurance, or we can have also some IoT device with the sensors that could move and collect also some GPS information as well. There is also the PAX counter that we already seen, that can mobile PAX counter are also bringing information regarding the position in which the activity has been performed. So let's go ahead. All this information regarding the mobile phone is collected and is very relevant. It is automatically collected and is very relevant. It's collected according to informed consent, so it is possible to use this information for collecting purpose, and specifically for providing feedback and suggestion to the single person. Most of this information is collected in terms of MyKPIs associated to the single person, and so it is possible for the user to remove some trajectory, to remove the data, and to manage and to delegate the access to each single element he provided to the platform. This is typically called the My Personal Data. So it's possible to understand how to exploit this part, how to define privacy rule on this, if you access to these test cases from the portal. You can also manage a data stream from dashboard back and forward. So the dashboard could be connected directly to the IoT broker in push by means of the IoT application, or in some cases even directly from the broker to the dashboard. So this is the pictures that remind you that the dashboard can be connected directly or mediated by the IoT hub. So this picture has been already discussed during the presentation of the IoT application. So it's possible to have in the dashboard some widgets that are considered the sensor for brokers, so someone that's sending data, and this sensor can be directly used to act on some actuators, or to go on the user interface, or representing something that is the value of the sensor, but also are sent in the data shadow and maybe are sent in another IoT application. So when you act on the user interface, you can really provoke a lot of activity inside the platforms, in other application, again in the data shadow, in the rendering, and also toward actuators. So sensors, actuators, and information that can come from the dashboard to the IoT hub, and from the IoT hub to the dashboard. All this information can be saved also on the storage, so is a way to perform a data ingestion, to keep track of the activity performed, and so on. So this is just a reminder, when you have some widget, you can activate some of those buttons, some of those elements can generate events into the IoT hub. And again, when you are inside the application, you may have elements that allow to bring this information in the graphic user interface. So there is a table that describes all this relationship, what you can do, what you can visualize, and so on. So it's possible from the dashboard to go inside the MyKPIs. So it's possible to pass from a dashboard to an IoT app, and in MyKPI is also a way to collect the data and to ingest the data. So the preference of the user could go inside the database. This is an example. So it's possible to set up some variable, some timestamp, and send this data on the KPIs. So it's also a way to perform data ingestion. So another view for data ingestion is what you can do with the GIS information, to import and export GIS information and the WFS, WMS data inside the platform. So the platform is compatible with the GIS data. So you can from the dashboard system, you can access to any GIS player, because the dashboard system is compatible with the WFS, WMS protocols for showing, for instance, images, but also for showing element coming from some GIS, geographical information system. In the same manner, the Snap4City platform that is reported here in this part is also capable to export towards a GIS system the information that it is managed by the Snap4City in terms of WMS and WFS. And so the platform is interoperable with all these kind of solutions, and it is possible to interoperate with any kind of GIS tools, and also with the Esri GIS. The solution is enforced directly into the virtual machine. So when you install the the main virtual machine and also the knowledge base service map virtual machine, you can find internally the interoperability label for GIS with WFS and WMS. In addition, there is also the GIS tool. GIS tool is a player that allow to play GIS information directly as external service into the widget of the dashboard builder. So here I am not going to go to explain all the details that are reported here, but to just expose some of the example. This is example A that refers to this connection. So it's possible to access to the Esri and put the Esri interface inside a dashboard of Snap4City. In this case, it is an access, it is a connection of our GIS player. So this is the Snap4City GIS player that is accessing to a GIS information remotely located. This is our data map that is getting the data. These are blue dots here, are elements that have been acquired by some GIS, and you can mix the information coming from service map with the information coming from GIS on the same map with the same selector. You can have both. Typically is WFS, so you can ingest single point, but also maps and also shapes and other information. You can have WMS integration. WMS means to have, for instance, background maps. You have in most of the maps in multi-data map of Snap4City, the possibilities to load the different kind of maps. So the different possibilities of background maps can be configured in the back office by the administrator, so it's possible to provide multiple choices for each organization. Another aspect, for example, is the possibilities of for an Esri ArcGIS, in this case, to access to our services for exporting service map information as a WFS. In this case, Esri ArcGIS accessed to our WFS, and so you see in the Esri interface embedded in the dashboard, you see the data that are also available in the knowledge base of service map. Finally, you can access again from to our knowledge base from ArcGIS Esri Pro. That is a standalone tool that you can install on your computer, and you can connect that specific tool to our GIS WFS interface from service map. This means that your GIS can access at the hand to our knowledge base by using WFS interface. You can also access to the WMS information, not only to the WFS information that we export, but also we export the WMS information. This is, for instance, the GRAL map, heat map regarding the NOx, so you can access even to that kind of information. So we have shown that the service map and so the Snap4City is fully compliant with GIS, is compatible and interoperable back and forward with the GIS tools, and protocols like UFS VMS. In addition, the Snap4City is also well integrated with the CKAN, so you can interact with the CKAN exploiting the APIs of CKAN, and you can ingest, you can federate a different kind of CKAN with the CKAN of Snap4City. It's also possible to activate the harvesting, so it's possible to keep aligned the CKAN in the Snap4City with the CKAN that you have in your location and vice versa, in a way that when we publish some open data in the CKAN, they are automatically exported towards your CKAN, and the opposite. So it's also possible to upload the dataset in the CKAN and to regularize the dataset using some specific tool that is called the Datagate. Datagate is a module that can be installed in the CKAN to help you ingesting data or providing data with the point of interest description. When you have regularized this data, the produced CVS or XML data can be posted in the IoT app that has been presented before by Michela Paulucci. So the automated data regularization is performed by the tool that mark which are irregular, unsatisfactory field with the red area, and you can work with the user interface to arrive at finalizing your table directly on the Datagate module of CKAN. If you need more information on this, you can access to these notes and you can test and use those solutions. So it's also possible to ingest social media data, and it's possible to do by exploiting the APIs or Twitter Vigilance. So Twitter Vigilance is a tool that can be programmed to collect tweeters from the twitter.com. So they are collected, and the number of metrics can be estimated. They are based on the volume of tweets, of retweets, on the ratio from tweets and retweets, on the natural language processing keywords, on sentiment analysis, and so on. So all these metrics can be shown, can be collected, exploited in the IoT app, and so you can really keep track of what is going on from the IoT app on your Twitter Vigilance. So this is done through a microservice that allow you to connect the Snap4City with the Twitters, with the Facebook, and with the Telegram too. So to give you an idea what you can do with the Twitter Vigilance, we can analyze and making prediction regarding the many aspects on people on football game, or marketability of consumer goods, or audience in TV programs, audience in scenarios and events, on several different issues, and also provoking some early warning, so you can keep track of what is going on in the Twitter channel, and maybe send a message when some of when the volume of your tweets in a specific topics is growing too much, is unexpected high with respect to the regular volume, so you can inform your measure or assessor that there are some activity in that area or according to the topics. So this is what how it's typically exploited. The Twitter Vigilance can be also exposed inside the dashboard, so it's possible to enforce this information, not only in the back office to create alarms and early warning and so on, but also to expose this information in the user interface and so on. This is an example of sentiment analysis. We see the keywords and with positive and negative, you see the trend. You can identify which are the critical cases, in which moment they explode and so on. Further reading on social media can be obtained from those test cases. So thank you a lot for attending this section. I have some acknowledgements as usual on what we have done and who have been the project in which and the activity in which we have done or what has been reported. So a lot of them, a lot of projects, Select4City, Snap4City, Replicate, Resolute, Ghost, Fair, 5G, Mosaic, Life, Garda. And the last one, Herit Data, Reverberi, and so many projects and activity, thanks to all of them. Further readings, again, so if you download the slides, you can have those links clickable, so you can start from them to jump directly at the interesting part for you.